This ransomware stuff. That's what I heard out of this, right? So hopefully you can come back and or we can have you do a virtual presentation from down in Cincinnati. So so next up, we're going to roll right into the next presentation. You good with it there? Let me get this switched over and put that on. And then just the clicker once I get you set up.
And Matt, I wear this. Let me know when you're ready.
Okay. Hey, so
It's working.
microphone's on the laptop.
Okay.
Not that I want to tie you to it, but all right. So I know we didn't have a lot of time for break, but we're gonna start with the next presentation. Dr. Phu Phung's over at UD, and after he's done presenting, before we break for lunch, real quick, we're gonna do some prize drawings. So
Stay.
don't run out fast. And I think the lunches will be here like right around noon. I think there was everybody already paid for lunches and stuff like that. I think we had a couple extras because somebody canceled. They ordered and they didn't show up. So I think if you're one of those ones that paid late, there may be a lunch available for you because somebody just ordered lunch and they didn't show up and they didn't pay. So now you get to eat their lunch. All right, so over to you.
All right. So you hear me?
Oh, no, it's off mute. Sure. Yep.
You there?
It was always off mute.
Am I ready?
Yeah.
Okay. Yeah. So thank you, John, and thank you everyone to stay here. So before lunch, this is a hard job time. I hope you still be here and my talk still interests you. So I don't have a slide about who I am, but I wear this hat from Matt. Thank you, Matt. I'm a hacker. Okay. So the reason I'm confident saying that because I train my students to be a hacker and I tell them like that. And Matt also mentioned hacker is not crime, right? Hacker is different from attacker that Scott mentioned. So we are good, right? But I just put it back. So so who I am? I'm a faculty member at the University of Dayton Computer Science Department. I joined UD 7 years ago. Yeah, not too new, not too there. So if you notice that in this conference, I think I'm only one from university. Do I?
Yes.
Right. So what is the talk I will give you today? Now maybe we may have some people on virtual. I know at least one. I invite. He's from Houston, so he works at the university at least, and I try to hire him next month. So I invite him. Yeah. So we have 1 hour. So I think maybe I will spend a couple of minutes to talk about some non-technical stuff before I go to my talk. It's a little bit more technical. So I know from John last night that maybe some of you guys have a top secret clearance. So I just want to clarify that you should not skeptical to talk to me because I'm a U.S. citizen, even though. So and I originally came from Vietnam. So I have a long journey to here. So I got my bachelor in Vietnam, and then I moved to South Korea for my master, and then I go to Sweden for my PhD, and then Chicago for postdoc, and then I land here. And I believe that I will stay here. So a funny thing that I want to share before my talk is that when I do my PhD, my main topic is about reference monitor. So reference monitor is the way that like related to you guys talking, like how we monitor the behavior of the system to make sure that the system will not, have been compromised or something. And it's funny that, that idea is come from, it's come from Air Force report based here in Dayton. And I never know something until I came here and I prepare my lectures. So in my lecture, it's like, oh, this is Addison and this Air Force Base report. So something, fun. So I want to share with you guys. So hopefully I will stay here for long. And also I will introduce a little bit about what I'm doing later on. So today, what I want to talk about is the recent research I'm doing in my lab. So what the message that maybe at the end of this, you may forgot about maybe some technical detail. So I just want to bring up like the takeaway from my talk will be maybe to answer two questions that you may ask before my talk. So the first question you may ask is, what the hell this guy doing over there? And the second question is, you may, okay, maybe my expected answer for you guys is, okay, this guy do something cool, have some impact, and it's state of the art. It's not like 20 years old, 10 years old, it's recently, right? And one thing that I want to note that is, tend to the organization, I know that this talk like before lunch is not a good time. However, my talk is exactly the follow-up topic of math and follow-up topic of school. They already explained some terminology, something that I will show you. Without their talk, maybe I need more time to explain about that, but thank you. So my talk will be related to that, right? All right, so the second takeaway point that I want to, I will do it later. The second point, and for the purpose of today is, I know Logan already talked to me. And the first, that is the question he asked me, right? So I already give you there. The second thing I want to do is, okay, can we do some partnership? As I see here, only me from university and you guys from industry. So that is the purpose for this talk as well. Okay, this is something I'm looking for my career as well. I don't want to be university do something that isolated with the industry, or industry do something like isolated to the university. I want to be a joint collaboration and long-term collaboration, long-term partnership, and that is I've been doing in the past 5-7 years. So I will show you later. Okay, so that is two takeaways that I want you to be aware of. I'm open to talk after lunch, during the lunch or something, right? And as John mentioned, we have a table over there to show you about what we are doing over there, right? So, okay, so a little bit long. So now back to the talk that I will do. Some of the terms that you already see from Scott, like malware, right? Ransomware is malware, right? And malware includes ransomware. So you guys do some technical stuff. Okay, how to understand the malware, how to analyze the malware. You need like IR, you need the technique of, analyze the so-called to understand, okay, this is the malware, right? So I doing the same thing here, but I didn't do it like manually. I do it using some technique. So the technique that I'm using now in this particular talk is hybrid image-based approach. So what is that? I will explain to you, right? So as you may know that I believe that in every of your computer, if you use it for your own, maybe you do not, but if you use your organization computer, I believe that you are required to install antivirus software. Do you? Right? And maybe I ask Scott this question. Like, is antivirus software can scan the ransomware? Yes or no?
It will scan it, it probably won't find anything.
Correct. That is exactly the thing that in the real world now. Antivirus software is almost dead with this kind of new stuff. They cannot do anything with this because the technique that George mentioned, obfuscation. Like, I believe that 100% of modern malware have obfuscation. Correct. And in that case, no of the antivirus software can detect that. Completely dead for this kind of new world, right? What they do, they just compare the, okay, in this malware, they have A, B, C, D, and they scan and they compare that. But nowadays, Scott already confirmed with me, right? It is not possible. So another approach for that is, like we do the machine learning. So machine is better than human. So they do some, so most of the machine learning approach for malware detection is they do supervising learning. Supervised means that they need some expert like Scott, like Matt to identify some of the features, and then they need to have some label. Okay, this software is malware. This software is not malware. So they do some, it's called labeling, right? And then they have an algorithm. So this algorithm is, we have something here. Yeah, so, right, so this is the algorithm, right? So algorithm here is to identify it is a malware or not malware. So in this example, it's car or not car, right? But before that, you see the picture here. I like this picture. And by the way, some of the picture I steal from internet, so I have a source here. So if you want to check, right? So they need, you see this picture, you also use this picture, right? Or you also use the picture about this. Like, they need some expert here, right? To identify first, and then the more sample they have, the better the accuracy of the system is. So let's say you say 90%, 92%, 96%. So the more sample they have, so the better they will identify the thing, right? So that is the a little bit about the field, right? The machine learning of that, detecting the malware. But that is just the overview. So in recent research, there are a lot of different approaches and direction to do this, the first step, the future extraction. And what is the future, right? So like what Scott showed for you is that like he need to read the code and then do something, right, to identify, okay, do this, do that. But machine, they cannot do like that, right? So the machine, we need to have some algorithm to do this automatically, right? So here is an overview of like what people are doing right now. So if you can see this, I like this picture because you see that can we use the mouse instead?
Oh,
yeah. So yeah. So you see that there's a lot of boxes here, right? So they have so basically there are two lines. You see two lines over there, behavior based or signature based, right? So behavior based means like, okay, they identify like what this program doing. Signature based means the traditional one, they will identify the code. So and then they will combine this together to have a different machine learning algorithm. So you see, like the bottom, there are a lot of different machine learning, right? So I ask you this question. In these pictures, what is the most important box that you think is will be have the most for the malware detection? Which one? So by the way, I started my research about like 20 years ago, but this kind of research I did like about like less than 4 years. So I'm still new in that. I'm not the expert in machine learning, so I do not know a lot about this one. All of the stuff that I'm presenting to you guys today, done by my students and collaborator. So, but what my question, back to my question, what is the most important? In my opinion, in our opinion, the most important point here is this toolbox. Feature. What are the features that you can capture to put to the machine learning? So, whenever you have a good feature, more feature, then the machine learning will do better. Otherwise, the machine learning will be like useless. What is the most important to machine learning model? If you ask the data scientist, is there anyone here, data scientist? What is the most important for data science?
The data.
Data, right? If you have no data, then you have nothing. So features are data. So in this case, if you have a malware, you have a data. But malware is not data itself. You need to have a step to put the malware into a data that can be understood by the machine learning models. So that is the most important step, right? And the work that I showing today to you is the one that our contribution. What is the step we are doing over there, right? So yeah, so normally, so what are the challenges of this? So there are two challenges that my research tried to do. The picture that I just cropped from over there. We need to have a step to do the feature extraction from the malware, right? And normally, as I mentioned, like Scott just showing you, right? Normally, we need an expert like Scott to do some identification. Okay, this malware have this data, right? So it will be very tough. So if you, let's say you imagine that like there's like millions of different samples of malware, like can you do it by human? Like that, like almost impossible, right? So if we do it like by machine, then of course it's much better. The second challenge that Scott already helped me to explain that, and I mentioned to you earlier, 100% of the malware nowadays, I call it modern malware, are using obfuscation technique. So that's why the antivirus software scan it and do not detect it, right? So obfuscation or backing or encrypting, that technique is called invasion, right? So they want to invade the traditional antivirus software, and to do that, they will create a new variants. So I highlight the variant, and Scott already helped me to explain that variant, right? And it's very simple. It's like in similar real world. We know about COVID, we know coronavirus, right? So that exactly the same thing in the real world, in the biology one. Like coronavirus in the version 1, they create like Delta variant, they create like another variant and variant. The same way here, right? So they write one and then they change the code, even though it's the same virus, but it's go to another version, so that they try to escape the detection, right? So these are two big challenges in the research that that motivate my research. So here I give you just example of the obfuscation, right? The real code is something like in A, you see it's 2 lines of the code. But then when they deploy the code, they will change it into B, so that the antivirus software will not detect that, right? So that is just example. And I give you more example. Good thing is that Matt Scott already explained to you, right? So for example, you see the original code, they put something, or they like you see here, they put something like you know this one, like some of you, the hacker, you know this NOP, right? NOP, like if you do buffer overflow attack, you know that, right? You put just the command that do nothing but just move the execution. So that is semantically is the same, but if you look at the code, it's different, right? Or backend. So the challenge here is that they will pass the traditional antivirus software, right? So that the challenges that when you do this kind of stuff, you need to deal with, right? So my research question and motivation is, can we have some method to still detect the malware, but can overcome this kind of the challenges? Let's say we don't need the expert. We don't care about what variant you have. If you are the malware, I detect that you are malware. Even you rewrite this to do something else, to put something else like obfuscation, right? So that is basically the research that I show you. And as I mentioned, this is the new line of research that I am doing in my lab right now. So, and by the way, I share something with you. I share with, we have a dinner last night with the organizer. I share with you that I believe that maybe new with you as well. So you, we are different world, but I don't think that should be isolated. It should be something, common, so that I join the community here. So normally in the academic conference, we have to pay money to be present. So for example, next week I have a conference in Spain. I will present, but I don't want to go. I do virtually. So even I do virtual, I have to pay the registration fee, $900. What? So maybe something new to you, right? But that we do every time.
Hey, we gotta start charging more.
So yeah. So that is the thing. So what I'm doing, the work that the reason I mentioned to you at the work there are two type venue to publish what you are doing in academics. So the first one is to present in a conference. The second one is to just publish in a journal, right? So to publish in a journal, nowadays more journals they charge money to publish, but they still have like the published one. So I published this in 2 journal, not conference. So I didn't pay. So the first one I will present to you, and of course we have like how many minutes? We have less than 30 minutes. So I will be very, very general. I will not go like in technical detail like Scott mentioned, right? So I just give you an overview of what we are doing to overcome the challenges that I just mentioned to you. And I hope that you know the challenge and you know the motivation. So I pause here for some question if you have, before I move to the detail. Yes?
In a biological system, viruses tend to mutate to variants based upon environmental pressures. Is there any way that you can observe the environmental pressures inside of the computer that would cause them to change, make a variant, or this to attack a certain client as opposed to somebody else?
You mean about the biological virus? Or?
In the computer viruses, they changed it for a reason when they do that, make the variant. was there a pressure that you can identify that caused them to change that variant? Like,
So
Maybe that might be more for Scott. Have you seen that?
That's kind of similar to when I started going over the ransomware attack, the way they evolve.
yeah,
The pressure is they start using like shadow copies. So the ransomware changed to delete the shadow copies.
so it's possible that somebody could put a honeypot in there, force them to make a change that will be identified.
So so it's basically a lot of it's not polymorphic, so they don't change themselves. An attacker needs to rewrite the code. And that rewriting the code.
So I think your question is the answer is very similar to the real world, like the coronavirus. Why they have a different variant? I think it's the same answer, right? They want to avoid, for example, in coronavirus, they want to avoid the vaccine. They want to avoid the right. So the same here. Like if you have detect them already, then they have no chance to execute it, right? So they have to change it to bypass that one.
Right, but sometimes you can get ahead of them with a vaccine in the computer to tell them, well, we changed something such as the shadow file.
Right. So this is kind of the battle. Right? So yeah, that's a good question. So that is the challenge that I want to do. So my objective of this work is that whatever you change from whatever before, I don't care what you change, but I can identify your behavior, and your behavior will be the same. Then you are like the same. It's even though you have a different variant, right? So I have two different approaches. So and two of these approaches, I use the image processing method. So that's why my title is called image-based approaches, right? So in the first approach, I call it HIT for more. HIT for more stands for hybrid image transformation for malware classification, right? HIT for more. So what we did is and of course, some of you may question, is that new? This technique is new? It's new, but it's just a little bit new. People already done that like 20 years ago. But why our work is still valid there? Because we do something like better. So that is the research, right? So we create the method that what we did is, we don't care about the code, right? We care about some of the semantics in the code. So what we did is we get the binary. We don't have a source code like the question I asked code, like how can you get the source code? Normally malware, you don't have a source code, right? This just executable file. So what we did is we combine the different image transformation method, and then we just get that. We combine the method, we just get the binary, and then we combine that, we transform that into the image. And we leverage that image to the machine learning world. So in the machine learning, you may know that the machine learning or AI is recovered recently because they started with the image processing, right? So for example, how Google recognize a cat, something like, you may know about that, right? So we leverage that. So we capture the feature of the malware by highlighting some of the important session in the image, so that whenever you change the big picture, the real big picture here is still stay the same. So we still can detect that, right? So we can carry some semantic of that. So I give you some example, right? So we compare with some of the method. So here, this is the picture that we use, we implement this. So let's say in one malware sample, if you have a method like this method, the first method, that image will be generated, that method will be generated. So we have different ways. So this is our method here. So you see that our method generates something, and if you look at by human, it's much different from the rest. So we also do comparison of this, the accuracy of this. So our performance, outperform of the rest, right? So what we did is that we proved that even though we have different obfuscation different backend technique, we still capture the malware, right? The different malware variant also capture, like, so we use this way. The reason for that is we based on a recent study. They say that, okay, even you create different variant, the global picture, the global structure still remain the same. So that's why the picture captured from that malware is still the same. So the machine learning model still capture that. So that is the new thing in our work, right? So I give you some sample. Like for example, if you give me the deny, then I use my method. I generate the picture like on the left hand side, and the malware is the one like in the right hand side. So I mean, in the human eyes, you can look at like different, but this is the method that the machine can be, detect, right? So we do some evaluation on that. We use some virus share, virus total, like some of you already mentioned over there, and we publish the code if some of you want to. So by the way, all of our project and research we publish it. We didn't keep secret, so it's there. So I put on the GitHub as well. So we have a lot of samples. So right now we have about 20 cases for the sample, and of course if we have more, it's better, right? So yeah, so that is what we have, and we did some experiment. We compare with some different method, right? So so if you see here, we still the method I highlight over there is our method is not like too high compared with other, but it's the best in this compared with this, the one that we have, right? And yeah, so like Scott mentioned about the we have a lot of more work that we can do. So for example, the ransomware, maybe we can try this way, right? Or we can do some other data sets. For example, how we do with Mac, how we do with Linux or just Android. That is a lot of other work to do, right? So, any question for this? Yes.
Do you have a preference for which database is the best? And the reason I ask that is because we saw with COVID this furthering of the research based upon the sharing of data in databases. Are you at a point that's analogous to the research of PEC that we've done with COVID to further get after the problem that we have with malware?
That is a good question. I do not have that information. So I can say like what we did is we just, we did a very ad hoc way. So I think that's a good idea. So we have some sort of like Scott mentioned, like, or Matt also mentioned, like virus total, virus share. We have some of the central one, but in these, they have like fish tank or something, right? So they share all of the data they have, right? But right, to have a central one, in the top of my knowledge, I don't know. I wish we should have that.
Do you think that would be helpful in the research to be able to attack the malware problem?
I think so. Yeah, I think so. So I know that there is the big data set is called cargo.com. That is the one that they share all of the data sets they have, but it's not only malware. They have, that is the idea that you're talking about, but they have all of the data sets they put. Right. Sure. Yeah. Yep.
The image comparison that is being done with this, is that pretty processor intensive that may not be available to a larger audience or a larger user than that the image? I would think doing the image comparisons would be pretty processor intensive. Would that normal people not have the ability to do that?
Correct. Yes. Yes. So this is with machine learning. So I mean, if we look at this, we can compare the difference, right? By your eyes. But if you look at, let's say, million of picture like that, how can? Now that's why the machine learning is better in that sense.
Why is that? What is machine learning?
Because they base, so I'm not the data scientist, so I cannot answer that question. Because so right now, like the more data the machine learning model have, the better they can identify. And that is, as I mentioned, that is not my expertise. Like that is the machine learning and AI. My expertise is in cybersecurity. So my work is to how to fit the more useful data to the model. But how the model detect that, I have no answer.
Yeah,
That-
I just to
Yeah.
add to that a little bit. So to help answer that question is those images, yes, they're intensive, but a lot of the newer graphic cards can spit through that pretty quick, right? So if you get a newer higher end processor on those, like an NVIDIA card or different types of video cards, they can handle images pretty quickly. But as far as the data set goes, right, it all comes down to the classification of being able to identify those images to be able to sort them into whether it's benign or malware, right? And so if you're doing it from an image standpoint, right, being able to help that classifier see the image and understand it. It's just like the old AI of being able to sort apples and bananas, right? It's just another image that is being used to help classify and be able to categorize those types of software, or the images in this case. So the better data that you have to train those, the better your results will be to be able to run it through fairly quickly, and you can script that stuff pretty easily. So does that help answer your question? Okay.
Yeah, thank you, John. Yeah, so yeah, that is like a lot of things to learn about, including myself. Yes.
So hit from all is basically just taking the binary, transforming it to create more features that the classifier.
More data. Yeah, more data feature. Yes. So that they can learn better. Yeah. Yeah. More data. No. Yeah. I mean, not more data, but it's more useful information. I would say more useful information. Yeah. More features. Yes. Yeah.
And that helps with the classification, classifier.
Right.
Yeah.
Right.
Is this sample, is this the entire code, or is this just a piece of the code?
Anti-code, anti-program. That is executable. So if you put that in your computer, it's running. Yes.
Do you know how many data points you're using for your models?
What do you mean?
So your learning models, do you know how many data points that you're actually putting into the model to actually
Machine
process?
learning data points.
You mean like how many features?
Yes.
Right.
No, for this one, we don't care about how many features. We just care like how we carry the sum of the piece of the code into the image. And all of these images are features. But my next work, I have a question for you for the next one. Yes, in the next one we have that answer. For this one we don't have because it's on the image. So we just we have some of that one. But let's say the one that I mentioned to you, your answer. I think the question you have is we capture this like. This is the question. I think maybe answer like the file session header, some imports, some entropy, and some we do some character-based technique. But we don't count like okay, feature 1, feature 2, feature 3. No, we don't count that. That's way.
Well, I think kind of the question, right, is that with your classifier, right, you have to have some type of features to be able to help distinguish benign versus malware. So I think is that what you're leading to?
Right. So that one in this work is a machine learning.
Yeah.
We do not identify. What we identify is here. Okay, what kind of feature that we can fit into? It's useful to the machine learning. So we capture, for example, like what is the file session, we transform into the image. What is the header, we transform in the image, things like that, right? Yes? No, we do not. We do not. Yeah.
Yeah, 'cause that's important.
Okay, that's more work to be done. Yeah. Okay, so let's see. We have 20 minutes, so maybe I will talk in 10 minutes more about the network. So, yeah, I think I hope that you get the big picture of what we are doing with this one. I think with this question, I believe you got the picture, right? So the next work I want to do is, I want to show you is, we also use the image technique. However, we use differently. So back to the question you have, like what is the feature we have, how many features? I don't have an exact question, but in the next work I have the question answer for you for that, right? So we use the image base, but we do a little bit differently. So we want to capture the behavior instead of just like the region of the code, and we transform the image. So we call that the image behavior base. And in this, we have different data sets. And back to question of, what's the name? Karina. So this is the challenge we have in this work. Like, how many samples we have to do the work? So this is the big challenge in this work, because we do it just for Java. And to find the sample of Java malware is a little bit challenging. So we have a lot of sample. I think we have about 40K sample, but to use with our method, we only filter in 4,000 sample. So I will show you that. But the idea of this is also similar. So whatever we do is that we will create an image for the machine learning, but the way we create the image are different. So what we did is that we will transform the Java. We don't have a code of Java, but we have it's not binary either. It's called bytecode. So when we have a bytecode, we use the interpreter. We transform it into the function call. Let's say function A call function B, call function C, things like that, right? So we call that inter-procedure function call graph. And we put that into the graph to have a relationship. Let's say function A call function B call function C. And then we put these together, we map it into the image. So that's the first step we do. So that is one. We abstract is called inter-procedure control flow graph, right? So we abstract that. Given that, we know the behavior, because behavior, I mean, okay, you call function A, you call function B, you call function C. What you do, like Scott mentioned about, like they call this function, they call that function, right? And the second thing we did is we add some additional feature that is including like like for example, some of the function that, let's say they encrypt the file, they delete the file or something like that. We put that together, right? So with that, we have the first step is that we use the bytecode interpreter. We generate it's called the dot file. This dot file means they do that. Okay, function A call function B, and function C call function F, something like that. And then we pull that together to have the graph. Right? So the graph we have is something like that. If you can see the feature, let's say they have the main point, and then this function call this function, this call function. But with this graph, it's very hard to generate the image, right? So we do 4 more steps. We divide this graph into the simple step graph like this. These two graphs are equivalent. You can see different, but actually it's equivalent. So we put this graph into the image. So that is the image, right? The second one is we also abstract some of the data, some of the feature. Let's say what is the function there, like function to encrypt the data, function to download the data. So we put that over there as well. So at the end, we use machine learning. As I mentioned, we have 4,000 sample only for this one. We also publish the data sets, and we do a lot of experiment, and we compare with different baseline. We compare at least two the same data sets for different method, and if you can see over there, our method is almost like 100% over there, like 98% compared with the previous work is like 91% or something. This work is much better, right? So yeah, so that is two different work, but we use the image processing method to detect the malware. So I mean, it's still the prototype. It's not like we can do it at software that we can detect, but I mean that is the good, starting point, and we want to do it further. Any question before I move to the next?
What is the difference between the image signal and alpha? Because your double load increases your...
Yes, so that is the machine learning question. Yeah, so in our experiment, we just do like the single load. It means that we just do it one time. So we have a double load. This is the kind of deep learning technique that they have a many layer. So layer 1, they train to layer 2, and then they put the layer 3. Something that the more layer is the better accuracy. Yeah, so that is the deep learning techniques, right? Any other question? So then I will talk a little bit about what I'm doing now and my future work, and I seek for the collaboration from you as well. So as I mentioned, this is my recent work, but it's not my work that I do like for my expertise, right? The machine learning is not my expertise. So I try to learn that as well. So my research for the last about, you can say, 20 years were web security. So my main research objective for the next 10 years is, so when you click on the link, right now we talk about click on the link, right? So right now there is some trend. I say, hey, don't click on that link. Don't click on that link, this link. It's dangerous. That's true, right? But how can you prevent people to click on link? Do you have any solution?
Disable the link.
Yeah, right. No, it looks like no way, right? So my research objective for the next 10 years or maybe 20 years is, okay, I don't care whether you click on the link, but I have a mechanism to say that, okay, this link is dangerous. This link is okay. So I mean, if you ask me that work, I have no answer for now. That's my goal.
There are some tools, websites that will tell you if those links are valid or not too, or they're malicious.
Yeah, Google had that. Like Google Safe Browsing, they have that. But the problem here is they cannot capture on. So the thing that I'm interested in is that Google Safe Browsing, they cannot capture.
Do a proxy.
We can work together. But I can give you an example that what I'm interested in, and I don't see the good solution. So I think that like everyone here experience, let's say Mark and I use LinkedIn a lot, right? I don't see any of you maybe not use Google. So you search something on Google and then you go to LinkedIn or you go to Facebook, you see the advertisement, even though maybe you use different computer. Did you experience that? Right? These are legitimate. That's no malicious. But who knows that they steal your information? So my objective is not just only detect some kind of like try by download or something. I want to protect the internet user from, a couple of different things. So that is my long-term goal. It's not just like the the malicious website that steal your information, but also I want to consider about the privacy and like. So just for an overview here is that I want that, for example, when you go to any website, some of the website they ask you to click on the it's called agreement, right? So you agree that we have this policy, you have that policy. So the challenge there is when they have that policy, for example, we do not steal your cookie, we do not say your information, but who know that who guarantee that they do whatever they try, right? So my research goal is to ensure that like we have some way to control this kind of behavior in the next future, right? So that one is the long-term goals. But the work that I show in here is the work that one of my master children did, and he joined me online. I think he's in California right now. So I just want to show you one of the steps that I go in that way. It's how to do the detection from malicious web page, right? So we just jump into one step over there. So what we did is like, and the thesis published last year during the COVID. So what we did there is we tried to do something different what people are doing, like Google. They have a set of the URL. So we do something different. So what we try to do is we try to combine the two work that I showed you earlier. The first one is statics. I mean, I don't care what you are doing. I care some of the data in the sample, and then I put there. The second work I did is I tried to have a function call, so it means that the behavior. So in this work, I tried to do like both together to do that. So we do static analysis and we do the dynamic analysis, and then we have some feature over there so that we can do the detection, right? So the work that my student Praveen he doing is mostly he built a static analyzer that they put the code. So the difference between the work that I showed you earlier is that in the web it's different, because in the web the source code is available, right? Because if you do not have a source code, then the web browser cannot run the code, right? So that's different. So that's why we can do using the abstract syntax tree here. We can analyze that into the tree. So we can capture some of feature, because anything you do, you need to convert that into the tree before you can execute it, right? So that is one. The second one we do is that we do the dynamic analysis. So dynamic analysis, what we did is we have a prototype earlier that we developed a browser extension. So this is my long-term goal. So if we can monitor what the website are doing, and we can have some behavior pattern. So which one is bad? So we can do some machine learning over there. But we are not yet that. We still working on that, right? So what we try to do here is we extract some of the behavior feature so that we can fit to the machine learning to do that. So we combine that two together, right? So right now we still stuck on the machine learning, the data set, again the data sets, and the how we do that, right? So we did with static analysis. Yes, we have a sample of 22K sample, but when we run the dynamic, it means that we have to run that in the browser so that we can extract. So a funny thing that is when my student did that, there is the email from NSA sent to the university IT, hey, your network is compromised. And they identify my lab from my lab and say, so, hey, shut it down. So what they did is they unplugged the cable, and then next day my student didn't know that, hey, why it's not connected to the internet? And he identified it's not in that got the outlet. He plugged back to that. So I have a bit problem with that. So, so right now I cannot do that within my UD network for now. I mean I still I have one. I think he's here. I want to hire one researcher to collaborate with me on this as well. And I mean, if you guys want to collaborate with me, we have a lot of opportunity here. Yes?
The question, I see your accuracy. Precision tree, random forest, so the highest. What's the relative cost?
That's a good question. We didn't have a lot of experiment on that yet. But I think we need more experiment on that. However, the accuracy here is based on just the static one. So we don't know whether it's good or not. We need to have more sample for the dynamic one. So that is my long-term objective, because I do believe that static analysis cannot show and cannot learn the feature, because the statics will not show the behavior. My understanding is that the behavior can give you better things. So, but we still stuck here. We're still stuck here. So we are working on that, right?
I agree that you're not going to see all of the external code at first.
Right. So as I say, this is just first step. But my long-term step is not just do this one. I want to have something integrated in the browser. So if there is some behavior that the browser detects using the model that I have, they can help the user right away. So yes. I have another master thesis, and they do that. So what I want to do is I want to build this into the browser, not the browser extension, because in browser extension it's still not have an own capability to capture all of the behavior, and it's too like the question is it's a lot of overhead. Because like if you want to monitor function A call, function B call, you have to hook into that. And it costs a lot of time. So the web will be delayed. Right. So correct. Exactly. Yeah. So okay, so I think that is we have a few minutes, right? Before lunch. So I hope that I will not disappointed you.
Thanks. Those images are really pretty cool. Are those available anywhere? If not, you should probably sell them.
Oh, we have no we publish here GitHub. Yeah, GitHub. One GitHub, the other GitHub. Yeah, we have it. We do not keep it secret. That is different from companies. I don't blame anything. That is the job, right? That is what you do. But at the university, normally we publish everything we do. So that is the difference. Yes.
So you say you have most of your samples off the online like sources. Do you have any checks in there for anything like keying? So
we do. Yeah, that is the mention that I mentioned to yeah, we have that, but they don't have a lot of sample in this.
Okay, yeah, that's,
right. They have a they have, but they do not have enough sample.
Yeah,
right.
Mess up your dynamic, and that's where the static comes in.
Yeah. So can I have like 2 minutes more? Just advertise what we are doing more in. Yeah, so that is my technical stuff. I'm back to non-technical stuff. That the second purpose of my talk, and I also put that in the table because we are sponsor of the conference, Gold sponsor, yeah, as John just mentioned, right? So I just put some slide about that. So one thing that I want to give you the message today is that I have not a friend. She work at she's doctor. I think she's my doctor or something. And she said, okay, I have a son. He interested in cybersecurity, but UD don't have that, so we went to UC. So if you still think that, I want to show you now, we have very strong cybersecurity over there. So the message today, Logan just asked me, right? So I think the first question I answered to you, we do not do old stuff. We do state of the art. We do at the edge, right? And the second thing is we have a lot of things there. Maybe you didn't know, but our computer science department is one of the oldest department in the country, like City One. And right now we have a lot of concentration along with the computer science. We have AI and data science, one domain, cyber defense is like what I'm doing, and software engineering as well, right? And this is the one that I have showcased over there for you that we just, and John just mentioned, we just achieved that like a couple of months ago by NSA. So it's recognized that our cyber defense program is recognized by national, right? So so we have like a crisis now. Can I share our story now? So we have a crisis now that we have a lot of students in our master program. 2 years ago we have about 150, and if you see now in the fall we have about 700 students. So Logan, welcome, and anyone else welcome. But the thing here is that all of these students, like 95+% are international students. So what I want here is that, okay, I want to encourage like more local people to aware about our program and to join us, and also to collaborate with us as well. And recently we have a PhD program, and I also want to encourage people consider about that. Right now, I know that it's hard for doing your job and doing PhD, but what we expect that the recession may come to light. So when the recession comes, some of you may rethink about education, right? So that is something you think in couple of years. So that is. So I think that.
Okay.
Yeah. What we have.
All right.
Thank you. So
again,
we're the hacker again.
Yeah, thank you for coming out, presenting. This is for
Thank you.
If you have more questions, he'll be around. So ask about getting enrolled in the master's or the PhD program, and so we can all get better at doing all this stuff. So we're gonna break for lunch, but before we do, is Jason out there?
Yep.
I think we got a drawing on a couple things. I don't know what you want to do.
Can I share and?
Yeah. Do you want to connect here, or do you want to?
I think you can just you can share that one.
Okay. We'll do it via Google Meet. So.
It is me or you?
It's
Yours?
not mine.
Yeah. No.
He brought it up for you.
Okay. Thank you.
Let me find my mouse so I don't stop.
Thank you, John.
Thank you. Good job.
Yeah.
All right.
Oh,
So it's all yours.
Need to.
You should be able to. Let me. Hold on. Yep.
Oh, one more thing. We participate in the Get the Flag. There is the Get the Flag on National Cyber League. So we participate every year. 1 year we will rank at top 20. So it's not good.